This is lesson 5.2.3, recursive sequences. In this chapter you have been writing equations for arithmetic sequences so that you could find the value of any term in the sequence, such as the 100th term, directly. Today you will investigate recursive sequences. A term in a recursive sequence depends on the terms before it. So 571 is, look at the following sequence. So we have -8, -2, 4, and 10. What are two ways that you could find the 10th term of the sequence? What is the 10th term? So one way that we could do it is we could just list out all the terms. So we currently have 4 terms. I'll go ahead and write those down. -8, -2, 4, 10. So if we keep adding 6, our next term would be 16. That's our 5th term. 22, 28, 34, 40, and finally our 10th term would be 46. So again, we just listed them out by keep adding 6. The other way that we could do it is we could write an equation. So one equation that we could write is, like we did yesterday, T of n. So since this is adding the same thing every time, it's just like a linear equation. So the first thing is kind of like our slope, or our common difference. So in this case we're adding 6. So it would be 6n. And then we have to look back and find our 0 term. So if this is our first term, if we would go backwards, we need our 0 term. So -8 minus 6 would give us -14. So after this we're going to put -14. Our 0 term is kind of like our y-intercept, and y equals mx plus b. Okay, now that we have our equation, we can plug in 10 for n. So we're looking for our 10th term. That's why we're plugging in 10 wherever we see an n. So we would get 60. 10 times 6 is 60, minus 14. And 60 minus 14 would be 46. So either way we did it, we got 46 as our 10th term. Okay, on to b. If you have not done so already, write an equation that lets you find the value of any term, t of n. This kind of equation is called an explicit equation. So we're going to have different types of equations. This one is called explicit, and this is just what we wrote up here, the t of n. So we'll go ahead and rewrite that. T of n equals, our common difference was 6, so 6n, and our 0 term was -14, so minus 14. C, the next term after t of n is called t of n plus 1. Write an equation to find t of n plus 1 if you know what t of n is. An equation that depends on knowing previous terms is called a recursive equation. So that's our second type of equation, is recursive. And just like it says, we're not starting with just t of n, we're going to start with this t of n plus 1. So we're going to write t, and then in parentheses, n plus 1. What that means is our next term. So I'll go ahead and write little kind of clues of what they are below each one. So our next term is, it says the term after t of n. So if you know what t of n is. So we're going to start with t of n. T of n is like our current term. So I'll write current under it. And then in this case we're going to put our common difference next. So our common difference here is 6. So we'll put plus 6. And again, that's our common difference. So next term equals current term plus the common difference.